Okay, welcome everybody. We are a little behind schedule, so I'll try to keep it short and sweet. And anyway, Vicky has the more interesting part of this presentation, which is sort of the highlight of on the side of the program. I'm just going to give you a quick update on the different things that are going on and what we have been doing. If I can advance the slide, that is. Okay, just a little bit about the team. Let's forget about top one and come back to it. Of course, we have our regular developers, Vicky, which you have seen. She's the applications manager. She does a lot of documentation and training. She has organized 90% of this conference. I mean, the practicalities in there. Ed, who's in the room, is the core developer, doing all the hard work, which underpins the code that we're doing. And Elisa, who's been working really hard with on AnalysisStructure over the last year and a half ago, together with the WPDB, where we're trying to streamline all kinds of things, and we have some data to show for later. Now, Luca, after completing his PhD, is now continuing to work on the AnalysisScreen. He is also the person who is most closely in contact with all our industrial subscribers. And Morgan is started in last September, as a PhD student in our group, working on AnalysisMetabolomics and starting to get that back up to speed. And hopefully we'll have a young lady called Frankie Andrew joining us shortly to help out with some of the admin. So that's in the works. Well, a few of the highlights that we'll be doing together with a professional web developer. We have completely revamped and moved our website from the old clone platform, which was hugely outdated. And I think we have a really nice looking and modern website now. We also got the forum, and that's mostly Luca's work, back onto another platform, which allows us to maintain it and do all kinds of the nice things that we were there. So that was quite a bit of work in the end to get it all done. Of course, we do our regular workshops. Just to give you an example of what we did in 2021. I mean, we were here, of course, last year on the conference. So we had this, we tried to have this regular schedule of workshops that we do. But if we go to 2022, then you will see actually there's a few more. And one of the things that we've been doing, we have been planning a number of dedicated online workshops, which we have been giving on AnalysisStructure, on AnalysisScreen, on macro writing. And then this one was our first in-person one again. And of course, we are now here. So these two are already planned for the fall. And we'd like to keep that up. And we've been discussing on how to do this. One of the things that we are going to trial out in the fall is sort of a 4-week schedule of drop-in hours where people can come, and we will schedule across different time zones to make that feasible also for some of the other people that are either in China, Japan, or on the West Coast in California. So that's on the list. If you have specific needs, then please do come and talk to us about it. Talk about specific needs. We did some kind of a questionnaire to see what the user were thinking of it. And that was mainly because we had been doing during lockdown and the last year these online workshops, and we wanted to know how that actually worked out. We got, I think, 20 responses or something like that. Yeah. Something like that. Not a huge amount, but enough to get some idea. So the numbers are more indicative. So they're being appreciated to do the workshops. That's good to know. One of the things that we felt in delivering online workshops, you don't see the people, you don't see what they're doing once, but it's really different from walking around the room. So how did that work out? Did people feel that they could ask questions? So about 45% it was okay. A little bit about, yeah, it's a bit awkward. And then clearly some people really felt uncomfortable in that sense. Now, yes, there's a mark. We put that down because we thought actually that's a way of doing this things for people following these, or for your colleagues to sit down together with 1 or 2 more people in the room. So you have like your local little group that you can talk and discuss with, but then at the same time, you know that there's also the online possibility to ask the questions while it's going on there. So clearly having it by a theme was good. So we're going to continue these themed ones as well. Yeah, we put up some remarks here. You probably have read that already. So showing that they did appreciate that. A little bit on the next one. Now, one of the great successes that we see, and actually it's still expanding, is our industrial user base. So you see here the list of people that are already subscribing to it. So we have 19 paying V3 licenses, 1 V2 license, and already 2 companies on trial licenses. And you see them by the color coding here. The bold ones we are actually actively in collaboration with to develop certain things. So that's mostly Luca's work, maintaining those contacts and addressing the needs of the individual companies there. So that's going really well. I'm very pleased about that one. Just as a reminder for those who are new here in the room, we are a collaborative computational project, and we have recognized partners in the project, which are listed here and distributed on the map. So just to give you some idea what we're doing with our partners at the moment, so this is just compressed the figure a little bit more. These are the partners, of course, those workshops, and some of them are given in collaboration with the partners and at request of the partners which are there. The screening efforts, so that's with the partners which are in there, where we actively develop the AnalysisScreen routines. Some more of that later by Vicky. The metabolomics, we have 2 partners. Marie is in the room here, and we also work with Birmingham to develop that and making sure that is going in the right direction. We have been implementing, and that's really very good. We have been seeing an uptake from partners and also other groups that say, oh, we'd like to implement our tools and we'd like to use CCPN as the development platform. So we're actually working with people starting to do that. So other people are starting to write code using the CCPN code base as the starting point. And that means that the development will go much quicker than that. So that's the red circles of the people which are there. And then finally, the NMR exchange format, like I said, that also involves the partners like Guy's group in the States, but also NMR Box and people in the field to get that all working. Now, that at this moment, I'm going to hand the floor to Vicky, because she's going to give you an overview of the new developments in 3.10. Now, this has taken some time, and I always do the analogy. We decided to redo the kitchen, then said, oh, we're going to break through and make it an open plan, and then said we put in the flooring, but probably should do the whole floor, do all the flooring. And I said, well, if we do that, we may paint the walls first, and then so it ended up a much bigger project than we had anticipated. But we have now released it, and some of the developments which I showed were made possible by the fact that we went back and did quite a bit of code reorganization. But it also has cute and really good tools in there.
So yes, Geerten has already apologized for what I was going to say. I remember standing at this conference last year, was it end of last August, saying, oh, it'll only be a few more weeks, perhaps a couple of more months, and then we'll be releasing version 3.1. And in fact, it was about barely 2 weeks ago that we released it. So Geerten has sort of explained why that is. The thing is that when we do our upgrade from version 303, for instance, to 304, we can just put all of that onto the download, so update server. And that makes it much easier for you as users. You just download the files, restart the program, and off you go. But moving to 3.1, we've had to do it such that you have to re-download the program off the website. But for us, that's a chance to make some additional changes. So we can make changes to the data model, the way in which we handle and store the data in the program, but also we can update the Python package that's shipped with the program. We can add new and updated packages and libraries. And so we've ended up doing an awful lot more of that, but with the hope that actually this will now stand us in good stead and give us quite a good long time to add new features before we'll have to sort of do the upstairs of the house and move to 3.2. So what does this mean in the program? Probably one of the first things you're going to want to do is import some data. We've completely rewritten our data importers. 3 things to note here. One is if you're using Brooker format, then we can now read in the NC-proc parameter and we'll automatically scale your spectra for you. So previously, if you wanted to compare intensities across different spectra, you had to always make sure you processed everything with the same NC-proc value. Now you don't need to worry about that anymore. And about pipe, sometimes looking at higher dimensionality spectra could be a little bit slow, depending on which orientation you were looking at them from. We're now using buffer files, so that should be much quicker. And then finally, we're now also able to read pseudo 3Ds. Of course, you might also be opening a project, so a project, say, from 3.0. Unfortunately, we've changed the project format slightly. So when you open a 3.0 project, you'll be hit by this slightly unfriendly pop-up. Basically, and as soon as you save your project in 3.1, you won't be able to open it again in 3.0. You can, of course, always go back by saving your project as a NEF file with CCPN tags. But mainly it does mean that if you've got a supervisor or perhaps another colleague who likes to look at your project from time to time, if you upgrade to 3.1, then they also have to upgrade to 3.1. But our hope is that with this new format, basically we're treating the chemical shift slightly differently. We're making the projects more robust, and hopefully we're going to have fewer instances of people getting in touch saying, help, something's happened to my project and I can't open it anymore. So hopefully that will improve things for everyone. We've also made some changes to our menus. So you can see here, these now sort of fall into line with pretty much every other software program from the 21st century. We've also made some changes to our right-hand mouse menus. So hopefully just sort of trimming them a little bit, making them a bit more user-friendly. So for instance, if you wanted to get the selected peak menu, you no longer have to find that tiny little peak. You can just click anywhere and go to the selected peaks part to get the sub-menu for that. So hopefully, again, this is, although it's a change, it is hopefully going to be a positive change for you. We've made some changes to the peak assigner. You can see the dimensions are now in columns rather than in rows. And we've also just tried to declutter it a bit, reduce the sort of myriad of buttons that were there. And I think it's become much more user-friendly. You continue to use double-click to make assignments or de-assignments, but then you can just right-click and we've got this new pop-up that we've created, and you can just tab through it and then press enter at the end, and it's all entered. I find that much easier. And again, to edit, either use the buttons at the bottom or just right-click. And as soon as you click outside one of these little pop-ups, that just cancels it automatically. We've had a number of people say they'd like us to improve the reference chemical shifts module, and that certainly needed it. But we've now back to a situation where your mouse movements are correlated between the reference chemical shifts and your spectrum displays. You can switch atoms on and off, and as well as having these various options at the top, you can obviously select your amino acid. You can also select to view all amino acids in one go. So hopefully we've brought this back up to the version 2 standard that we were all used to. You'll also see some changes to the left-hand sidebar. So what was data sets has gone, and we've replaced it with structured data, data tables, and collections. So structured data is a place where you can save, obviously, the kind of data you need for structure calculations. So that's mainly restraint tables of varying types and also violation tables. These could be tables you've created within the software, or they could be ones that you've imported from perhaps your structure calculation software. Data tables are essentially a way for us to just store any kind of fairly generic tabular data. For those who are into their Python, it's basically a pandas data frame, and it enables us to not only store the data easily, but also manipulate it very quickly and with few lines of code, particularly if you're Luca. We then have collections. So that was literally a way to collect stuff together. Any data item here that you have in the sidebar, technically any object can be placed into a collection. You can even put one collection inside another collection. And so that's the way in which you can perhaps group things together that you find useful, but it's also going to be a way in which we increasingly group things that we perhaps want to use for some sort of data analysis. And I'll show an example of that later. So all of these changes are changes that we've made to the sort of underlying AnalysisScreen program. But alongside that, of course, we also have screen, structure and metabolomics. Each of those also contain everything that the sign has, but they then also have some one sort of extra menu with bespoke features for that type of analysis. This is now the first time that we're actually issuing AnalysisStructure as a standalone program. So you can start that simply with structure.bat on Windows or binstructure on Linux or Mac. So rather than assign.bat or binassign. And when you open it, this is the additional structure menu that you will get. It's got a number of features around dealing with your nosy peaks and then structure calculations and validation. I'm not going to go through any of this because actually a lot of it is still being quite heavily developed and it is going to change over time. We have got an up-to-date tutorial which will take you through all of it, but we'll make sure that as we introduce changes, we keep those tutorials updated for you. So instead, what I'm going to do is just take you through just sort of slightly more conceptually what we're wanting to do with the structure side of things. So the sort of old way of dealing with your structure calculations would have been this sort of classic iterative cycle of moving between your data, converting it for whatever structure calculation program you're using, getting some outputs and iterating through. And if you start with one structure calculation program and then you perhaps want to refine with a different program, you'd have to sort of start a separate cycle, as it were, because you need to turn things into a different kind of format. And it's actually relatively difficult and not terribly easy to compare different runs with one another, particularly when they've come from different programs. So in a way, you sort of end up a lot of the time working, as it were, in series. Another big problem that we've always had is been that stereospecific and non-stereospecific assignments have not been treated or catalogued and documented correctly, so that a lot of the time, actually, some of the features that are available in certain software packages, you can't really make use of properly. So what we're now proposing instead is that you start off obviously with your NMR spectra, and then we're now using the new NMR exchange format as our output format, and then we can use one single NEF file to actually start structure calculations in any of the main structure calculation programs. Those will then give you as output, again, other NEF files containing the data that they've generated, so restraint and violation lists, and we can then read those into analysis again, and then this time directly compare the output. So for a single peak, you could see, well, how has ARIA assigned that? How has Explore assigned it? How has Cyana assigned it? You can look for areas where you've got similarities and where you've got difference. And then obviously you can always go back to your data again and start that cycle. So we're sort of moving to a way in which you can, if you want, work as it were in parallel. And the NMR exchange format has obviously also been designed to make sure that now we are treating the stereospecific and non-stereospecific assignments correctly. And it's really taken a long time for us to get to this state. It feels a bit pathetic to say it's taken us 20 years, but of course one has to remember that compared to, say, X-ray crystallography or EM, where they just have one type of data, we've got all sorts of different diverse types of data that we're dealing with. We've got the distance restraints, we've got dihedral restraints, we've got RDCs, and then people keep inventing new experiments with new types of data, and so we've sort of had a moving target at times. And then on top of that, having to find a format that all the different developers are willing to sign up to has been quite a task. But I think we are finally getting to that point where this works. I say getting because this precise figure at the moment, I think Elisa is probably the only person who can actually do this. ARIA and Cyana, unfortunately, still have a couple of things to sort out. ARIA, there's still one bug on the ARIA side. Benjamin, if you're still around, we really hope that you can sort this out soon. And on Cyana, they're also still working to an old NEF specification. So hopefully when Geerten sees Peter in a few weeks' time, they'll be able to sort out getting that arranged. But of course, you can already use Explore with, doing different runs with different parameters and then directly compare the results. Within the program that looks sort of like this, you've got your table with where you can sort of compare the different restraints that have been generated, and you can go directly to your spectra, and you can obviously then also directly see your restraint on the structure. Validation is obviously also an important part of doing our structures. What many of us would like is for Geerten to resurrect his ping code, of course. I think unless someone provides him with a 2 or 3 month sabbatical, that's not going to happen anytime soon. So in the meantime, we are working together with the WWPDB with their validation pipeline. And so we can now read in their validation reports. We've started with some scripts that also sort of create additional useful summary tables. The next job is going to be creating some nice graphs, also making sure that we can automatically send off to the server to get these reports, so you don't have to fill in the web forms and that kind of thing. So this is sort of where things are at with analysis structure. I think that the basics are pretty much there, but obviously there's plenty more to fill in. So that's been primarily Elisa's work together with Ed. Luca has been continuing his work on AnalysisScreen. We've continued our collaboration with the NMR group at Novartis in Basel, particularly on the 19F screening. And Luca's been implementing continued improvements and tweaks to the algorithms and pipelines and the user interface. And I think we've now got to a point where we can really do robust and efficient analysis, even of quite challenging data. When I say challenging, I'm being British polite, so I'm not being Dutch direct. One of the quite nice things that Luca has recently implemented, which I thought I'd show, is that you can take 1D spectra and now interactively move and rescale them. So you simply select a spectrum as being current or active, and then with the options key and the arrow keys and the mouse wheel, you can then move them around and rescale. And that's obviously something we're used to from using TopSpin, many of us. And I think particularly for the screening community, so many people have been used to doing a lot of this stuff by hand in TopSpin. And it's actually really important for them to, in order for them to start to learn to trust all the kind of automatic algorithms that we're throwing at them, they also need to be able to sort of go back and look at this by hand so that they can learn to trust all the other things that we're giving them. Luca's also been working with Orion Pharma in Helsinki. They've been creating a new library, and so they've been using our mixture generation module. Again, Luca's been adding a few tweaks to that. He's added the option of adding these well plate identifiers, and then really nice, you can export it directly in the format that the Brooker robot needs to do its pipetting. Obviously, other brands of robot also available. If you need their export formats, let us know and we can add that in. Morgan has now joined the team and is working on the metabolomics side. He's done a number of things. So he's starting to create a database for us based on the HMDB. He's been doing quite a lot of curation of their data as he's been doing that. He's created a nice way of simulating spectra using a range of different parameters, and then more recently started looking at binning and bucketing algorithms and matching algorithms. So at the moment, none of that is actually implemented in software. He's going to start doing that in the autumn, I think. Things on metabolomics also now starting to get off the ground a bit more again. So that brings us to the beyond section, what was coming after 3.10. Well, the problem here is always that our to-do lists are not so much as long as our arms, but as long as Mr. Tickle's arms. And so it kind of always feels like we're sort of in this constant sort of setting priorities and trying to work out what should we do next, what's important, what users really need. And of course, everyone needs something different and it's all really important. This is just going to give you a little bit of a sense of what we are prioritizing at the moment. Luca has been redoing the chemical shift mapping module. He sent me this screenshot the other day, which at the moment it looks at first glance not an awful lot different from what we had before, but actually the details are very different. He's changed an awful lot of the underlying code and made it a lot more flexible. You can see now we're using these collections in order to group our peaks. And that means we can be a lot more flexible rather than just using your backbone HN. You can use any group, you can have multiple groups per residue. You don't even have to assign your protein if you don't want to, all that kind of thing. We've also got a number of different options now available here in the settings. We're providing the equations so people don't have to keep asking us, what equation are you actually using for this? It should be much easier now also to implement additional fitting equations and that kind of thing. And then something, again, lots of people had asked for was this sort of gradient view in the histogram. And of course, that will then also be, get that same gradient when you plot it onto the structure as well. The nice thing about all of this work that Luca is doing on this chemical shift mapping module is that actually an awful lot of code you're going to be able to recycle when working on the dynamics module, which is next. Because basically you're doing the same thing. You're grouping some peaks and then taking one of their properties and fitting it to an equation. And here we've sort of committed to get this ready by the autumn. Fred Muscat, who's our NMR facility manager at Leicester, is keen to do a dynamics workshop in the autumn, starting with the data collection and then going through processing and data analysis. So we were going to get that ready for him. So if you're interested in learning about dynamics, watch that space. Then another big job that's we're going to be starting soon is sort of having a really proper synthetic peak list module, being able to create all sorts of different types of synthetic peak lists as you could in version 2. It's going to be quite a big job, I think, but it needs doing. And then what we're going to do is go back and look at the assignment side of things. So the assignment was sort of one of the first things that was implemented in the software, certainly before my time at CCPN. But really, as things have gone on, there are quite a lot of gaps there actually that we now need to go back and fill. So that includes speeding up working with many strips, having a more generic peak matching algorithm, making improvements to the pick and assign module. That was actually something we were discussing in the workshop this morning with someone. Having more flexible strip plotting, which will hopefully also benefit people who are doing carbon detection, and some better tools for sidechain assignment and navigation. And of course, we also want to then start interfacing with automatic assignment programs. And then alongside that, obviously, as I was saying, we're going to continue what we've been doing with AnalysisStructure and AnalysisMetabolomics. And then I think something that's really exciting for us is some of the new collaborations that are starting to open up. So with Harry Apanari's group in Harvard, and also some folk in Grenoble and Paris. So we're looking forward to that. So it just remains for me to say thank you to a fabulous CCPN team, the people we're working with, everyone, a huge number of people who've been involved in NEF, and those who went before us whose work we are building on.